what do you need to consider whenever when choosing different size sorting tools? What do we to separate a mixture? What do we need to consider?
We need to consider size of the particle.
Yes, we need to consider the size of the particle. Some people said B. All right, doesn't matter how pretty the tool is. Do we care? Okay, and we just want to use something. It cannot be either B nor C. We have to think about the size of the particle. Okay, so if you do not have that in your notes, once again, now is the time to go ahead and put that into your notes. All right, remember, can I have somebody read physical property for us? Can I have somebody read what is a physical property? Wow. Let's go. Lante, go ahead and read this out for me. You gotta be just as loud as Norman. Alante, going once, going twice. Cecil, be ready. Cecil, go ahead and read this for me. Physical property.
Are a characteristic.
A characteristic.
A characteristic that describes a substance such as color, size, and texture, shape, or texture.
Beautiful reading, right? So we have to think about the physical property. All those things matter, and also thinking about the size of the particle or the object. All right. Ooh, y'all about to see my stuff. You can't see my stuff. All right. So now I want a prediction. Okay. Mr. Bangurah, I was assault. Okay. And I had some water. I was trying to make some salt water. My tooth was hurting. All right. And I added 5 grams of salt into 15 milliliters of water so I could just gargle and help my toothache. Okay. How many grams do you think will be in our solution? How many total grams do you think will be in our solution? And how do you know? I want Deshaun Carter, talk to me. What you thinking? What you thinking? What you said, Deshaun?
Wait, so you asked how do I know?
Yeah, how you know? How you know? Okay. All right, perfect. So your math, so you use a little bit of math. Yeah, right. And so this is the part of science where we use a little bit of math. All right. And so, Deshaun, what you just explained is called the conservation of mass. Everybody say it in your screen. On 2. 1, 2. Conservation of mass, right? So mass can be changed, okay, but it can never be destroyed. All right. So in our solution, if we have 5 grams of salt and 15 milliliters of water, what will be our total amount of grams in our solution? What will be our total amount of grams in our solution? Thank you to everybody that's going ahead and typing the answer in the chat, getting points. Getting points. Haley, was that a typo? Yes. Okay. Yes, Ash. Beautiful. So we have boom. We have 20 grams of solution. So now we see what it looks like from our own eyes. Let's see what it looks like under a microscope. And please do not laugh at Mr. Bangorah's painting drawings. I don't think is that funny. Okay, but all right. If I drop my salt in here, look how it's all clumped up. One of the things I want us to pull out of this is that my salt spreads through my solvent or the water evenly. Okay, it spreads through it evenly. This is something, and this is actually my fault. When I was making my slides, I should have put this on the notes, but go ahead and capture this down now, that the particles in a solution spread evenly. So I have a trick question. All right, if I mix my salt solution, does it just stay at the bottom? Based on what we see in our demonstration or in my picture, does it just stay at the bottom? Ashley.
If you mix it around, it's like it spreads evenly across the cup of the water.
Perfect. All right. Think about your Kool-Aid when you're making your Kool-Aid or your orange or your juices or whatever you're making, right? Oh, that's a good follow-up question. All right. My next question is, does the amount of salt particles increase, decrease, or stay the same? Does the amount of salt particles increase, decrease, or stay the same? Interesting. Will the number of particles change once it dissolves? Okay. So if I only add 5, so if I have a total of 20 grams, once I mix in my solution, did I get more salt, less salt, or is it the same amount of salt? Graylin, unmute. Tell us what you thought at first, and then tell us what you think now, and why.
So at first I thought it would increase, but then now, because since there's like the same amount of salt in Kool-Aid and inside that own water, now I think it's the same.
Yeah, it's this exact same. Okay, so that is a conservation of mass. You can change the shape or the form of it, but it's still the same amount of particles. Okay, so notice how I didn't count each and every particle, but notice how it's the same amount of particles, but now just spread out evenly in this picture. Okay. So now we're gonna have a quick CFU, and then we are gonna jump into our edge elastic, which should take us until the end of the time. All right. So go ahead. You have 3 questions. It shouldn't take too long.